Hello everyone and welcome to GameEsc. I am Alt4Master and I'm sorry it took so long for me to make this video on how I made the contest winning Battleship machine. If you don't remember, there was a machine contest done by this very game, Creativerse, and the winner got to bring home 2 pro keys and 2,000 coins, and I was one of those lucky 5 winners that ended up winning. Now, a lot of you have asked me how to make this, and sadly I was not able to make this right away for you. The main reason, because during the contest, while I was making it, I had to go on a trip, so I decided, against my normal nature, to bring my computer so I could work on the machine. And on the process of coming back home, my computer had fallen and my whole hard drive broke. Now I finally got my laptop fixed, and now I can bring you this video. Now I'm going to show you a very dialed down version of the Battleship game, the one that I created. Now, if you ever make a new machine or any type of machine, I've got to suggest do it on paper first. And even when you fail doing it on paper, keep doing it on paper. I have my graph paper here to show me exactly how I did this. So, in order to do this dialed down version, you are going to need 2 LED lights, 2 delay gates, 1 inverter gate, 3 logic gates, 2 number pads, 2 number comparison gates, 2 flip-flop gates, and 1 switch. Now, the first thing I decided to do while I was going here is to try and get the repeating blinking light. Now, for those of you who didn't watch my video, I suggest you watch it. I'll put a link in the description below. Basically, whenever my opponent had put up their ship and that ship light was turned on, then the light would blink. But if it was turned off, the light would stay on. So, here we go. This is going to be my board. This is going to be, let me go into it. This is literally going to be my LED, the vertical game board, and we're going to make this on the grid 1-1. Now this will be in the bottom left hand corner all the way down there. And now the first thing I usually do is I turn off the interact. I want my machines to be interacting with my LED lights. I don't want myself to interact with it and do something weird. So we're going to create a very easy to make repeater with a delay gate and an inverter gate, and then we're going to attach a logic gate to it just for safeness. So I'm going to put my delay gate right here. Now, in making this, I have got to tell you, naming convention is the biggest thing, okay? Especially on the scale that I made it. Mine was a 10 by 10, and this is what I'm showing you is only a 1 by 1. I had to multiply everything by 100. So these 2 LEDs, I needed 200 LEDs to make one set of a game board, and I needed so much more. It was crazy. So what I do is I send only the name of the delay gate. So this is going to be the delay gate. Delay gate repeat, which I'm going to make it much easier so I don't have to write the word repeat over and over again. The DGR, delay gate repeat 1, 1, grid 1, 1. That's what it sends. Now, We'll get to that later. The 1 second can't interact. That doesn't really do much. Now, because of that, I turned that into the LED. You're going to receive the delay gate repeat 1, 1. Bam. Done. See? Connected. We're done. Sounds good. Next thing you're going to make is the inverter gate right here, which, guess what it sends? It's going to send the inverter gate repeat 1, 1 for the grid 1, 1. And this inverter gate is going to receive the delay gate repeat 1, 1. Bam. Sounding pretty easy so far. Next thing we're going to do, now that we have those two set up, is I want a very, see, I could add a switch to this and just let it blink, but you never get it to stop without a logic gate. So here's the logic gate. We're going to input 2. We're going to make the input logic gate 2 inverted gate repeat 1, 1. Bam. We're not going to worry about the other input, and the output is going to be the logic gate repeat 1, 1. Now, what I failed to mention here is that the logic gate is going to, this guy here, the output will be sent all the way to the delay gate. So logic gate repeat, grid 1, 1, save. Now this will be really easy to test, and I suggest it's just like how everyone always says, save, save, save. When you're doing something like this, test, test, test. Okay? So how are we going to test this? With a simple switch. We're going to pick up that switch later, but with a simple switch, I don't care what it's called. If I press F, it blinks. Perfect. If I turn it off, it stops blinking. Great. Let's pull that one back up. Let's clear that here so we have a nice fresh face. And this is our blinking light. Okay? When you make these machines, very seriously, make them. You're going to make a gigantic machine like this. Try to break it up into small portions first, okay? You want to start off with the smallest thing, which was the blinking light. I don't have to worry about this blinking light. I know this works. I don't have to interfere with it. I don't have to touch it anymore. We're good to go. Okay, the next smallest part, we're going to make this thing turn on if the other guy isn't turned on, okay? So, this looks like a good spot. Boom. 2 number pads right here. We're going to do this very easily. This is going to be X pad. Done. Make it a reset timer 6 just in case you fumble around and you need some more time. Don't press the F button, press the N button. Then we're going to make this the Y pad. Okay? Very easily said. The X-axis, Y-axis. X-axis pad, Y-axis pad, Y pad, X pad. Y'all have got that. I don't need to explain that anymore. Now, whenever you're going to have a number pad, you need to go straight into a number comparison gate. Now, those are really easy to muster up. Bam. Input 1. Going to be very easy. X pad. Here we need to make sure we're inputting the number 1 for X pad. Sends out what's going to send out. Very easy. Number comparison gate. X-1. This is basically the number comparison gate that says that the X-axis is 1. Save this here. Wait. Almost, yeah, I did put it on value. Save. Over here, same thing. Y-pad. Make this 1. Turn that into a value. And number comparison gate Y1. Okay? Now, very easy to test to make sure that this works. Grab an LED light, boom. Let's go ahead and that up. Me not being as smart as I can be. Let's grab this logic gate here. Let's go here. This is going to be X-1. This is going to be Y-1. It's receiving the number comparison gate, which I forgot. Number comparison gate of X1 and the number comparison gate of Y1. X is equal to 1, Y is equal to 1. Okay? Now, output logic gate. Logic gate. Huh. We're not going to worry about that right now because we are going to go straight into testing this thing. Okay? Let's make sure that whenever we put in 1 here and a 1 here, that light will turn on. 1, enter. 1, enter. Boom. And it works. Now, the question that you're probably asking is, well, it worked, but why is that light turning off? Very easy. And this one took me a little bit. I thought I had to go through a wild number of things until I realized they have a thing called a flip-flop gate. Okay? So, we're gonna make this logic gate. Let's make it hit. Right? Logic gate, flip-flop gate. Yeah, let's just call it hit. And 1, 1, boom. Save. This one here receives logic gate hit. 1, 1, boom. Save. Let's send it. Boom, right there. Let's try this again. 1, enter. 1, enter. Turns on. And 5, 4, 3, 2, 1. Doesn't shut off. Perfect. And if I wanted to turn it back off, I'd have to do that. That's how the flip-flop gate works. It's going to send out a true, it's going to change it to true, and then it's going to change it to false. I am planning on doing a nice tutorial for all of these machines at some point, at some time. But today I'm not going to explain how each one of these machines work. I'm pretty sure if you want something as complicated as what I'm making, you've already got some sort of understanding on what all of these things do. Okay? We don't need this LED light here. What needs to happen here, this is the flip-flop gate that will turn it on if I turn this on. So what we need to do is we need to connect this one. We're going to call this, we're going to turn on the LED light, right? Which over here is called delay gate repeat 1, 1. Now this is, I could go and mess all of this up and try to connect this to here, and then all these other things are going to happen. Quite honestly, the easiest way to fix any remedy of where you have something kind of like this, where two things are going to hit it, and if both of them work at the same time, you get weird results. So what I like to do is I like to come over here, right where that delay gate is. I'm going to come here and put another delay gate. If you ever need a nice space and you have naming problems where you need to name two things differently to send, but they're going to the same thing, it's going to change the name to whichever. It only can have one name. So you send them both to a delay gate and you are perfectly fine. So right here, this was delay gate R11. Let's let this receive. What were we going to make it receive? Let's let this receive delay gate R 1,1. Actually, yeah. Right? Yeah. And then this is just going to be the LED light, that the vertical one, because in a battleship this will be the vertical facing wall. 1,1. Okay? Don't need any delay on there. That's just how it's going to be. We're going to go ahead and kill that name right there. Okay? LEDV. We're going to go here. Well, I can just do this. Nice thing to know, no one told me in all of these tutorials that everyone says you can literally highlight by just clicking on it once or dragging and pulling, and the famous Control Z, which is copy, will work. Boom, done. Don't need to spell check all the time. Let's save that here, and now we can come over here to our flip-flop gate, call this LED 11. Boom, and we're done. So now guys, remember this isn't connected to anything yet, so that will always be false. This one true stays turned on. We are done. Okay, we have basically made both situations. Now I'm going to turn this off. Done. We have made both situations work. Now we've just got to check whether or not it is another battleship. Okay, now most of you say, well, if it is a battleship, this section here will still turn on, right? That's fine. I don't care if this gets turned on, because even if it's not a hit, even if you didn't hit the other person's battleship, it doesn't matter. I need this light to turn on anyways. But if it does hit, I want you to turn on, and then I want you to start blinking. Okay, which is this section right here. Now what we're going to have to do is we're going to have to create the enemy battleship. I'll put him all the way over here. Let's turn off this. Something else people never said. Okay, I thought I would be able to do this with just LED lights. I can't just do this with LED lights, because if you look, this LED light can only receive objects. Okay, it can only receive a signal. It can't send out that it's turned on. It can't send out that it's turned off. But guess what can? You guessed it, the last switch we have in our arsenal. Now this switch can send. So opponent's ship, which I probably spelled that. No, I didn't spell that wrong. Perfect. Turn. Check to see if that turns on. Perfect. We're good to go. Okay. This will send a signal saying that that light is turned on or that light is turned off. Now, for all intents and purposes, we already know that this works if it's turned off. It's literally got a direct path. So let's turn this on and see if we can get it to start blinking. Now we have 2 more machines left, guess where they're gonna go? We literally need a logic gate next, because we've got to check to see if this switch is turned on, and if this has been hit. So we'll put our logic gate down right about here, press N. This is literally going to be the opponent's ship. Did I capitalize the other one? Let's see if it connects. It connects. Perfect. And this one is going to be the logic gate that hit for 1, 1. Perfect. Okay. Now, output. The output for this is just going to be logic gate 1, 1. Perfect. Done. We haven't used the send part yet. Now, here's the next part. We're going to use the last one, the flip-flop gate, to tell that it's true. Okay? This here is going to receive our logic gate 1, 1. Right? Is that correct? I figured out my naming convention is completely wrong. Give me a second while I fix this. Watch this. This isn't LG hit. This is just LG. And this sends the hit. Now we gotta solve one last thing right here. This is just an LG. Now, for those of you who don't understand what I just did, it was my mistake. I am sorry. But this isn't what determines whether or not you hit a ship or not. This guy, this logic gate right here, determines whether or not this light is turned on, which means that we have hit a battleship. Now it's going to go and tell this flip-flop gate to turn on. And I believe you can guess exactly where this flip-flop gate is going to send. This is our flip-flop gate hit 1, 1, right? Boom. Now, y'all are still like, where did that connect to? Where is that going to connect to? There's one thing that doesn't have a input, and that is right here. Flip-flop gate hit 1, 1. Save. Alright. Boom. Right there. Now we're connected. Everything's connected. We have we're going to start off all the way at the beginning. Both of these here, X pad and the Y pad. Perfect. Now, this is going to get if the input is equal to 1. And right here, equal to 1 for the X pad. Perfect. They both get sent to this logic gate, which says that this light needs to be turned on. Logic gate 1, 1. This thing sends. Not just to here. See, this is why you always go back, because this here, in my haste to change everyone's name, I forgot to change this one as well. Gets sent here and turns on this light. Doesn't matter if it's hit or not, because even if it's not hit, that light still needs to turn on. Now we're going to check whether or not you have the logic gate here, and now opponent ship. Oh, look, here's the opponent ship. This light is turned on. This means that this is going to become true, folks. And it gets sent to the flip-flop gate, which will turn it on indefinitely, just like we learned with this flip-flop gate. Everything looks fine. You got the logic gate here that hit. Now you got the flip-flop gate that hit. Now you're saying, yes, it hit, and yes, the inverter gate is turned on. Send it to the delay gate. Okay, here we have delay gate repeater, the delay gate repeater, which is going to receive from the logic gate repeater, send, boom, all the way to this inverter gate, which is going to send back to this logic gate in a loop. And this, if this is turned on, boom, send it to this delay gate here, boom, LED light, Whoops. Don't press the letter G. You've got to press the letter F. That's what that just taught us. 1, enter, 1, enter. Light has been turned on. 3, 2, 1. Turns off, turns on, turns off, turns on. Every second. Alright. I would like to thank everybody who subscribed to this video at GameEsc. I am Alt4Masta. You can expect a lot more videos from me in the future. Thank you and goodbye.